Good morning, everybody. I'm Megan Terry. I'm the service hydrologist at the Weather Service in Springfield, Missouri. I have been at Springfield in a few capacities in my almost 23 years in the region. So really looking forward to sharing some of the maybe not so new and some real cutting edge and very new information with you about some hydrology tool development that's been going on in the Weather Service. So, whoops. Okay. So first I want to share with you some information on HEFS, the Hydrologic Ensemble Forecast System. That is something that is available to you now, and I'll do a quick navigation to show you how to get there. We will have some web page changes coming up. Many of you are probably familiar with the river pages linked on our website. We call them AHPS, but there will be a transition going on there over the next year. Also, the National Water Center has been developing some products and some applications. So just want to touch base on those real quick. And then, some of this I'll be able to give you a rough timeline of when it'll be available to you. So with that, the Hydrologic Ensemble Forecast System. So the point of doing an ensemble forecast system, and this is with respect to river levels and forecasts out to 10 days, we're attempting to quantify the total uncertainty in the forecast flow. So those sources of uncertainty are going to come from your forcing uncertainty, mainly that would be precipitation, because that's what's going to put all that water in the streams and make them go up, right? And then, but there is also hydrologic uncertainty that needs to be addressed, whether it's soil moisture, maybe flow in between river gauges. There may be some inputs and outputs that you can't account for directly, but do our best to model those. And we also want to, as much as possible, remove any biases in either one of those sources of uncertainty. And there's a lot of information that goes into this, and I'm certainly not going to quiz you on this flow chart, but just kind of wanted to show you it is a complex process. And so the values being put in river forecast, precipitation forecast out to 5 days, and then there's a global ensemble forecast system, take precip, other types of data, 1 through 15 days, and an NWS climate forecast system. We'll use that as input also, and it kind of helps with seasonality issues. And there is also some climatology that goes in. So that all gets processed and do some statistics on it, addressing the biases and adjusting for downscaling to basin level, and then getting post-processed. And so inevitably, we want a product. And so the way to see this product, if you start from, I assume most of you are in the Springfield area, but if you're not, you might be in St. Louis's area or Kansas City's, but you want to start with the main Weather Service page, and then up near the top, there's a Rivers and Lakes link. So if you click that, you'll go to your main Advanced Hydrologic Prediction Services website. And then from there, the third tab over is called Long Range Flood Risk. And then you can click on that and it will show you all the points that you have long range river forecast available for. Okay. And so currently we have some long range forecasts that go out about 3 months. In addition, we also have weekly forecasts, and it's just telling you the probability that the river will reach a certain height. It usually defaults to this weekly chance of exceeding river levels. But if you go to the short-term probabilistic guidance, that's where the HEFS output is. And if it is available, most sites have it now, not all of them, and I'll go over which ones in our area have them. But when you get there, what you're going to see is 10-day forecast. So anything over here left of the red line, that's observed data. So it's already happened. And then we'll go out 10 days into the future for the HEFS forecast. Well, I guess that's a little redundant, but anyway. But one thing you're going to notice is that you see next to no variability early on, and that's just an indication that all your models are in agreement, you know, all your precip's in agreement. But then notice as we go a little bit into the future with this particular site, this is the little Osage at Horton, where you're starting to see an increase in your probabilities here, indicating, yep, there's some rain expected. And how's that going to impact the river? The most likely scenario is going to be shown in this blue line. So this is indicating the most likely scenario is you're going to start getting rises between 7 a.m. on the 27th and the 28th, and it's going to gradually crest somewhere between Friday and Saturday and then start coming back down again. But you notice that you do have a spread, as the ensembles will show. Ensembles are just varying your initial conditions a little bit, and you know, total maybe about 50 or 60 different variations on the model runs here. But the output from that, so most of the outputs show that your river levels are going to end up somewhere in this blue area. And then there are a few outliers as you get farther away from that median line. So if you are, you know, if you're real sensitive to a certain river level height, you know, and you can't even tolerate a 5% chance, and you see something like this, you know, maybe potentially getting up to 46 feet with the higher end precipitation, that might help you with planning activities down the road. So the next thing I wanted to show you, I did a little verification on this particular site. So I clipped this image on the 25th of October. It's the same one that you saw on the previous slide. And then 4 days later, I took the observed hydrograph and a little bit of forecast and saw how it compared. So around 6, 7 a.m. on the 29th, we were at 35.88 feet, which yeah, is pretty close to that median line right there. So you had a pretty high probability of getting to that level. And then I went ahead and included the forecast peak here. But, you know, you might see it diverging a little bit, but actually the timing of the crest isn't that bad. You know, it's pretty close to being on target there. So that is HEFS. So the current status in our area, again, it's a 10-day probabilistic river forecast product. We have 3 river forecast centers that develop these depending on where you are in our forecast area. So Arkansas Basin, their display may look a little bit different. So anybody on the Spring, Elk, Shoal Creek, that area, if you look at your HEFS forecast, they'll probably just be all blue, but just know that this darker blue is your highest probability, and then it gets lighter as your probability drops. And then with Lower Mississippi and Missouri Basin River Forecast Centers, they do more of this color coding where you get the blue for the higher probabilities, and then it tails off to green and this peach orange color as you get a little farther away. So that is one other thing about HEFS. We do have those available for our forecast points on the James, Spring, Elk, Osage, Sac, Jacks Fork, and North Fork White rivers, and in those basins. They are still being developed for the Gasconade Basin, so they're not quite ready on the Big Piney, Ruby Doo, and Gasconade. So I believe that is my first stopping point. Do we have any questions? And I have Steve kind of monitoring that for me.
Sure enough. Megan, yes, we do. Austin Arnold with Greene County Office of Emergency Management asked, is there a way to receive alerts for a certain threshold on these waterways like other hazards on INWS?
The USGS does have alert capabilities. So you would need to go to their website, and actually, if you could write down an action for me, I'll get that link and get that to him. It's not for the forecast though, it's only for the observed. But if
Megan,
that was suffice.
I'll also try to find that while you're on the webinar today as well.
Okay.
Any other questions for Megan at this time? Go ahead and type them into the GUI, the GoToWebinar GUI, and we'll be glad to ask. She has a couple additional stop points in her presentation, so we'll have plenty of opportunity to answer any and all questions. With that said, Megan, why don't you go ahead?
Yeah, right. And just to elaborate, if you think of something later about this section, we're going to have question and answers at the end. So no worries there. Okay. Next, I want to talk about some of our web services that will be coming online. Most of you are familiar with AHPS. That's our version of River Page. And you can get river levels and forecast for those river forecast points. There are, about 8,500 gauges across the U.S. About 3,600 of those have forecast. We have our forecast responsibilities for those through the river forecast centers. But, you can just click on a point that's color coded, indicated, anything in green is not in flood. If it's in yellow, we call that action stage, is getting close to flood. Orange is minor flooding. So it's right near flood stage, and then higher thresholds as you get to red, which is moderate, and purple, which is major and or record. So you can see that instantly when you look on the page, and then you can click on the points and look at the hydrographs, what's happened in the past and what we're expecting in the future. You can look at some of that probabilistic information like I just showed you. There are some static flood inundation libraries, and we're going to be talking a little bit more about that here in a bit. Also some precipitation data that you can access. Some of you may also be familiar with the National Water Center's image or interactive viewers. So what the National Water Center does, and this is through the Office of Water Prediction, they generate analyses and forecasts for stream flow anomalies, soil moisture, and precipitation. And they do this for all river reaches across the United States. There are 2.7 million river reaches that they do this for. They do their analysis every hour, and I believe they run their forecast every 1 hour to 6 hours, depending on the short-term forecast is every hour, and it goes out 18 hours into the future. Medium range goes out 10 days, and the long range goes out 30 days. So how cool would it be if we could combine those two, right? So this is actually the plan over the next year or so. We're going to combine both of these services, and we're going to lump it into the National Water Prediction Services website. So again, we're combining all the AHPS information and the water model information. They're also doing some behind the scenes work just to make it more mobile friendly, downloadable. One nice thing about the hydrographs is they're going to be more dynamic. If you visited the AHPS page in the past, you have kind of a fixed time period that you can look at. It's usually 5 to 10 days in the past, maybe 5 to 10 days in the future. But with this application, you're going to be able to expand and contract, and you can hover over and get a readout of stream stage and stream flows. So again, more dynamic. There will be more flood inundation mapping. In fact, the plan is to develop flood inundation for all the stream reaches that the National Water Model has, which I think is just super cool. And it's in process now. It's going to take a while to get there, but they already are doing some work, and there is already a little bit of data out there. The only diversion is that the precip data, it's kind of hidden in AHPS anyway, but it's going to be moving over to the NCEI, National Centers for Environmental Information. It's going to be moving over to that website. And I have just a couple of samples. Current samples, they may be adjusting these, like work in progress. So here's a sample of CONUS with river gauges, and it highlights the ones that are in flood or getting close to flood. And it looks like they also brought in some watch warning advisory shading in those areas that are having flood issues. So again, this is just one sample. It's GIS based, very interactive. And here's a couple more samples. So the one on the left is a flood inundation sample, and the one on the right is the hydrograph with the past and future. And then you would adjust the range with the scroll bar down on the bottom. And some of you might have seen something like that already on USGS. They have new gauge displays that they're using. It's very similar to that. So most of it, the timeline, when is this going to be available? So first, it's not available right now. Even I can't get to the website. But I saw this presentation last week at an agency meeting and just really wanted to get it out there and share it with you guys. So it's going to happen in late April to late May. They're going to do a parallel run with both AHPS and NWPS. At that time, you will be able to look at it and provide feedback. And I will put information out on email on if and when that gets out. Well, it's not a matter of if, but when it gets out. They're also, they'll take all that information, and they're also going to put it in, if they can incorporate it, do a stability test during late summer, and if everything goes well, final deployment in September of 2022. And I'm so pumped, I can't wait. But any questions about NWPS before I move on?
Megan, I am not seeing any, but just to repeat, with those 2.7 million sites, obviously that is just a terrific improvement from where we're at right now. Incredible, I should say. Will the inundation mapping be part of that initial rollout, or do you think that'll be coming over time?
I think it will be a part of it, but it won't be available for the whole continental US. I think it will be available for coastal areas, especially to our south and east. But it, as time goes on, it will become available. And I did have a note here too. When we discussed yesterday, we're here to help with interpretation. And so if you start seeing some of the stuff, you're not quite sure what's going on, contact us, shoot me an email, and we're here to help pass that information, interpret it for you, coordinate it with you. So with that, let's go on to National Water Center products and services in development. So the first one I want to hit on is the National Hydrologic discussion. This is going to be a daily text product, but it incorporates the whole US. I think a lot of the issues that some of our higher level national customers have had is there's not just one place to go find this. You got to pop on to different weather service sites, different river forecast center sites, things like that. So this is more of a one-stop shop for all of your overview of flooding across the US. So it's going to incorporate urban flooding, small stream flooding, larger river system flooding, flash flooding, ongoing. Now within the product, it will break it down by regions. So you see these little blue bookmark things here. So, if you're along the Central Gulf Coast and you don't want to read through all this, you can just click on that and it'll bookmark you down to that section. So should be a very quick, easy read, but it's going to address the types of flooding and potential impacts, again, from time it's issued out 7 days. There's a companion graphic that goes with that. It's called the Flood Hazard Outlook. And I really like this because you could just, I love the picture worth 1,000 words. I can get so much information just from looking at this. So it highlights the key messages over here on the left. And then I'm zoomed in on the little legend down here. It's a little fuzzy, but I think it helps to blow it up a little bit. But they're going to use color coding for potential impact. So if you see any pink areas, that's some potential for catastrophic flooding. And then it goes down with darker blue, considerable, and limited in the light blue. So we see for this particular outlook, it's mainly light blue. And they also use some line hatching to show, which time frame are you looking at? You're looking at 1 to 3 days, or you're looking at 4 to 7, or maybe all of it. And I notice there's more of a crisscross hatching over here in New England. So that would be a longer term. And again, using the color coding for those areas in flood or expected to be in flood, and the level, the highest level where it's minor flood in the orange, moderate in the red, or major in the purple. So again, that's still being prototyped, but I would look for that to be out probably within the next year or two. Okay, the flood inundation mapping. I think this is going to be a really neat service, and I'll do my best to describe it for you. But so currently in AHPS, we do have around 190 locations that are typically river flood forecast points, and there were extensive studies done on them to generate this static library of flood inundation. So you click your point, and then you can change your level, and the colors expand and contract depending on how high or low you are. Okay, but these things take years to develop, and they're fairly costly. So with interactive flood inundation mapping concept, the goal is to do this flood inundation for all 2.7 million stream reaches. So you're saying about the water center already has flow for those stream reaches, and we already have forecast points and gauges with flow stage relations. So what they want to do is relate that stream flow to stages and potential inundation. So they use this method called the hand method, height above nearest drainage. So, and that's kind of this little grid I have in the upper left here. So what it's basically doing is for every stream stretch, it designates it as a 0. And then as you go away from the stream, the numbers get higher and higher. And that helps you to simulate how the water is going to flow in. And then once you have that information for each basin, you can pretty much, let me go back just a little bit. For each basin, you can pretty much fill it up and get inundation coverage. And you also need the flow stage relation or the rating curve for each of these reaches. And this is Manning's equation, hydro geeks out there. But so they run this for every stretch, and they're creating flood inundation mapping library. And this is a display within their WaterView application and potentially within NWPS. I'll show you that in just a minute. But as of early this year, those areas in the blue are where they have done this already. So again, all up and down the East Coast, a lot of Texas, and of course they're working their way northward and westward to eventually get the whole continental US done. As a cross-check, they're going to use those sites that have already had flood inundation mapping done, and they'll do some verification statistics and comparisons to kind of help calibrate things so that you eventually get a better product. So, and there are people at the Water Center that really get in the nitty-gritty of that. I'm just wanted to share the information. I'm kind of 25-foot level, so if you have any questions about the specifics, we can pass those on to them. But one thing we do have already is it's called a categorical flood inundation mapping library. So they've done this already for just about all of the river gauges as the forecast points. And then they use the color coding to match up with the colors that they use on the points in AHPS. So anywhere, in yellow would indicate some potential flooding when you're at action stage, and then the orange when you're in minor flood, red, moderate, and purple, major. So you get this graphical aerial extent of flood coverage based on your flood categories. And here's a sample from the Spring River. So this is the reach this is Carthage in Jasper County, and it flows northwestward, eventually goes by Waco and to Baxter Springs, Kansas. And so based on those action, minor, moderate, and major levels, you can see where those areas would potentially flood out. Now it just gives aerial coverage, it doesn't give depth. But and this application I'm going to show you in a minute, you can actually tweak it to where you only see one category, or you can mess with the transparency a little bit and zoom in and zoom out. So it's got some nice functionality. Okay, should I break there before I get into WaterView, or should I keep going, Steve?
I guess I do have a question for you. And using that Spring River as an example,
I'll go back to
how many days in advance would you anticipate the Weather Service to have a feel for what might flood versus after the rainfall has occurred, and we would be able to graphically display these inundation maps that you're describing?
Well, right now within WaterView, I think they can do 5-day in advance for those areas that they do have mapped out already. And I'm going to show a sample of that in just a little bit. So they can input the rainfall and then produce the stream flow, and then correlate that to the flood inundation map and display what could potentially be flooded.
And again, I want to go back to what Megan said at the last break. Some of the stuff is pretty high on statistics, especially the rainfall to come and how we're averaging out all the models that are giving us the amount of rain that is expected. So in chat, I did include a message. If we can help you interpret these, we would strongly urge you to give us a call or get in touch with us via NWS chat. And of course, there's the DSS event support form that we offer to emergency managers as well. And with that, I do not have any other questions, so please go right ahead.
Okay. So this application also developed at the Water Center is called WaterView, and it's GIS based, and you can display base analyses every hour. There's also information on short range forecast that goes out to 18 hours, medium range that goes out 7 to 10 days. Those flood inundation, or they call it aerial of maximum flood extent. And I'll have a sample of that here in a bit. And you can also display graphically the observed rainfall, usually past 24 to 72 hours, and the forecast rainfall out 10 days. So the first image, and I mainly just have clips of these. They are doing some work on this website, so I won't be able to access it live today. But the first thing I wanted to show you is just kind of an analysis, the base analysis product. It'll mainly highlight those areas in flood. And one cool thing that it also does, if I can get it to work, yeah, there we go. So notice how they use triangle symbols for those areas in flood. Well, depending on the way the triangle is facing, you can get a tendency. So anything with an upward pointing triangle is a trend, the forecast trend. So it's at major flood stage there in Eastern Virginia, and it's still going up. So good information to have. And then you might see a couple where the arrows are pointed down. Of course, that would be here's one in New York, decreasing trend. And then anything in the circle would be a steady. So not much change there. Okay, so that's kind of neat information to have, and legends are included. Another thing you can look at is average stream flow percentiles. And I think it'd be a really neat tool to use in operations when we're looking at flood potential. So, maybe we have a few inches of rain coming out here in Oklahoma, but you see that your flows are running below normal from this legend over here. So you might not be quite as concerned about flood potential from a heavy rain. But then, go up here into Illinois and Indiana where it's all high and much above normal, but you get a few inches of rain on top of that, you may have a lot more problems because you're already starting at high levels and fairly saturated. Another tool, this is in their short-term forecast, it's called Rapid Onset Flooding, and it highlights the basin that is expected to potentially have problems due, from the rainfall forecast that is within their model. So one thing you can see it highlights is it gives you an estimate of the percentage of the length of the stream that would flood. So here's the Sac Basin north of Springfield, and it's whoops, let me go back again. It's thinking that anywhere 30 to 50% of the stream will be flooding, will be out of banks. And then it also, by the color of the stream, it gives the duration. It gives the onset duration. So again, a lot of information to glean from this, but just seeing those colors pop up on your basins when you have a flood event going, it's like, or you have an event coming up and you see something like this, like, well, maybe I need to keep an extra eye on flood potential for the next 18 hours. And then this next one is actually a combo of 3-day and 10-day Bankfull arrival times. So, and I've zoomed in a little bit. So it's giving you an estimate on when you're going to flood based on time with the coding over here. And I believe the 10 is the top. So for this particular stream, expecting out of bank within the next 12 hours, and then kind of, it's like a routing forecast almost. Midstream, you're looking at maybe 3 days down the road, and then 5+ days as you approach the Mississippi River. So again, I think very useful information. And here's a sample of the flood inundation. I believe this is actually this is out way east in Virginia, but yeah, just for this particular stretch, and you do have to zoom in quite a bit before you see it. If you were out with a full continental US, it might just all be colored blue in some places. So you got to zoom in pretty close to the area that you're concerned about. And then this one here is like a 5-day maximum flood extent based on the stream flow and the level that they think it's going to reach. Okay, it's very useful information. You can also pull in past precipitation. This is a 72-hour past precipitation image. And the legend over here gives you an estimate of the amounts there, as well as you can pull in forecast. This is a 10-day precipitation forecast. So you can kind of see what are they putting into the forecast from the rainfall, and then the output shows up in the stream flows. So WaterView status, still very much in development. In fact, there are only currently there are only 4 people in our office that have access to it. But we we can share that output with you. The only thing we ask is that you do not release it publicly or put it on any social media pages, since it is still prototype, still in development. But we can certainly look at an area you might be interested in and let you know what the water model is showing for that area.